Hello everyone and welcome back to the IGCSE 0606 Additional Mathematics course. In this video we will be covering chapter 11, which is permutations and combinations. So let's get started. Now, before we dive into the actual topic, let's discuss about a new operator, that is factorial, which is represented by an exclamation mark. This acts on a singular number and it's defined as n factorial is equal to n times n minus 1 times n minus 2, and then we keep on multiplying until we reach times 1. So obviously the times 1 can technically be omitted because any number times 1 is just that thing, so really it's still times 2, but we go till times 1 for completion, obviously, because it's a bit more formal like that. So if we look at the an example of, let's say, 5 factorial, 5 times 4 times 3 times 2 times 1, using the definition, and then if we calculate this out we'll get 120. Now, an important note is that 0 factorial is equal to 1, which may seem confusing at first, but I can show you the proof for it basically. So if we take that 1 factorial is equal to 1 from our definition as defined above, right? So we say n factorial is equal to n minus 1, n minus 2, so on till 1 basically. So we can also say that n minus 1 factorial is equal to n by n minus is equal to n factorial by n, actually, right, by n. If you like try and rearrange this equation, really you'll just get n minus 1. So we divide by n on both sides, we get n factorial by n is equal to n minus 1 factorial, because that's going to be the same thing. So if we put n is equal to 1 into the equation, we get 1 minus 1 factorial is equal to 1 factorial by 1. 0 factorial is equal to 1 by 1, which is equal to 1. And so we've proved that 0 factorial is equal to 1. This may seem a bit complicated. You don't need to know this. You just need to know the fact that 0 factorial is equal to 1. So now that we've covered that, let's go to the main topic here, which is, so let's start off with permutations. This is permutations. Okay. So the formula for permutations, we'll talk about where this is used in just a second, but basically NPR is equal to n factorial by n minus r factorial. So this is why the previous knowledge of factorial was relevant here. And so a permutation is basically when you're given some objects and you have to arrange them in a line, with arrange being a keyword. So if you ever see in the question arranged or a synonym to that, that means that you have to use permutations. So there are two cases: arranging n objects, so that's just n factorial, and then arranging r objects from n objects, which is npr, or you use this formula. So let's take some examples. Let's say I give you 5 apples that are all different in some way or form, right? So we say that the number of ways of arranging these 5 apples will be 5 factorial, which is 120. Now let's say you have 5 apples, but out of these 5 you only want to arrange 3, so that will be 5p3. Now so 5 factorial by 5 minus 3 factorial, which is equal to 120 by 2, so that is equal to 60. So there are 120 ways of arranging 5 different apples and 60 ways of arranging 3 different apples from these 5 apples. Now different is a keyword here because there's actually a different condition when the apples are all the same, but that is currently out of syllabus for you. That is a part of AS level math syllabus, which if you continue with Cambridge you'll be doing next year. Now if we come to combinations, this is the other part of the chapter, combinations. And so this is the formula. So if you look at these two formulae, you can see that NCR is just NPR divided by an extra r factorial, and we'll come to this in just a second, why NCR is lower than NPR, obviously, because we're dividing it by an extra number. But what combinations is when you're randomly selecting different objects, essentially. So obviously there's only one condition here, selecting r objects from n objects, which is NCR, because, well, if I gave you 5 apples and I told you to select 5 apples. So we select 5 apples from 5 apples. Well, there's only one way of doing that, right? Because you select all 5 of them. But then I tell you, I want you to select only 3 apples from the 5, right? Then that becomes 5C3, which as we, okay, so let's say we use 5P3 here, we found to be 60, and then we divide it by 3 factorial again, this gives us 10, right? Now, why is that? Well, if you actually think about it logically, let's say I'll represent the apples using these numbers, right? Let's say 1, 2, 3, and then you've got, let's say 1, 3, 2, or 2, 1, 3, 2, 3, 1. This is, so I'll just list these 6 combinations here of, like, if you were to take 6 apples, basically if you were given 3 apples and you had to arrange the 3 apples, you would have 6 possible combinations because 3 factorial is equal to 6, and these will be the 6 combinations that you have. But because we have 5 apples, that actually becomes 60, because then there's a lot more ways, this could be 5, 2, 3, or let's say 3, 4, 2, things like that, right? So this is arrangement where you can have multiple things. But then if we come out to combinations, 1, 2, 3 and 1, 3, 2 are the same thing, right? We've selected the first, second, and third apple. This one again, we did the same thing. The order we're selecting them in does not matter. Here, the order matters. In combinations, the order doesn't matter, and that is one of the most, I guess, differentiating factors between these two things. But yeah, that's about it for the topic. I would honestly recommend you to practice questions, because permutation and combinations are fully logical based questions. I cannot obviously teach you how to think, right, for a specific situation. I can only show you the basic concept and the formula, and obviously factorial, because that's a new thing. But yeah, just keep practicing questions for this topic. Understand where you went wrong and why you went wrong. Why is your thinking different from what the marking scheme says to do? But yeah, thank you for watching.